So if we run this function to calculate all the gene correlations, we're ending up with a new data frame with all the genes and then the Pearson correlation coefficients. And we get that for the 17,000 genes and the p-values and the Spearman values as well. So how many values do we have where the Pearson coefficient is smaller than 0.5? And that's 1566. Let's have a look for the Spearman p-value. So how large is that? It's 1400. So about 1500, 1400 genes are significant. That's a huge amount. And that's a problem. So we can sort this, and then we see that SLU7, which is quite interesting, is the top hit. It's got quite a strong Pearson correlation of 0.5 and a strong p-value. So that looks very convincing. We also got some positive controls here that we know proteins we know are important for ATR. So A-trip, RPA1 comes up. So this is completely unbiased data mining, but it brings up the expected genes already. But you know, SLU7 looks interesting, and it's our top hit. And it's a splicing enzyme, so we don't know, does ATR have anything to do with splicing? It's not really an obvious link, so that could be interesting. But is this real or not? So that's really what we need to look into now. And for this, we are running into a problem. So, and this is called the multiple testing problem. So this, we can explain this best using a coin analogy. So if I have a coin and I flip it 20 times and I get 15 heads, I might be suspicious that something is wrong, because that's quite unlikely to get that in one go. If I do it 17,000 times, I have a chance of 5% to get 15 positive heads. So I actually have quite a large number of times I will get a positive result, but this will be by pure chance. And this is like that in any statistical test where you do something over and over again. So in our, we test 17,000 genes. So there is a good chance that from the 17,000 genes, there will be false positives. And with a p-value of 0.05, we would expect about 860 or so to be false positives. So we need to find a way to say what are false positives and what are true positives. I'm not going to go into the maths of this. There's different methods, but what in the end, what we end up is the false discovery rate. And we will use a standard method, which is the Benjamin-Hochberg method. You can read up upon it. It's going too far to explain you how this works. But again, there's a nice SciPy function that we can call to calculate that, and that will correct the p-values, and it will shrink our data. But the data that we get out will be much more higher confidence. So let's have a look how this works in code. We again from SciPy stats we import false discovery control, this function. This function takes two arguments, which is our Pearson p-values, and we can also supply the Spearman p-values here, and the method. And the method we use the BH method here, and we know that now we want to set our new threshold again to 0.05. So we can say that our adjusted p-values are significant only if they are larger than 0.05. And then we can see what happens in the output. So let's have a look how this looks like in real life. So here, this is the FTR correction function. And if we run this, we're shrinking our data set from 1566 to 27 and only 3 in the Spearman. So the Spearman is much more stringent, but this is good because now we can say, okay, those 3 must be 100% definitely positive. And look here, for example, even RPA is ruled out, although we know that RPA interacts so we're probably a bit too stringent with the Spearman test, but A-trip, for example, is a true one. So here A-trip is true, and that seems to be that is definitely a true interactor. What about SLU7, which we had before? That is still significant in in the Pearson, even with the false discovery rate applied, but not anymore in the Spearman. But I think in this case, we are just going ahead with SLU7 because that looked interesting, and the Pearson correlation efficient is quite high. So I thought this is quite interesting. So we have to test this further to see is there really maybe an indication that there might be an overlapping function between these two genes. And that's what we are going to do next.